One way of adding and subtracting vectors is by using their components. Okay. A single vector has one pair of x and y component. The vertical component is what we call the y component, and the horizontal component is what we call the x component. And these two components of a single vector are perpendicular to each other. So it means they can form a right angle. The magnitude of this vector A, it is represented by A, which is the magnitude of this vector, vector A. The magnitude of this vector is equivalent to the length of this line. And its direction from positive x-axis to the vector A is theta. With these three lines, the y component, the x component, and vector A, form a right triangle, right? So how can we determine the magnitude of the y component? By getting the sine of this angle, theta. The sine of angle theta, or the sine of the non-right angle of a right triangle, is equivalent to the opposite side, which is 8y, over the hypotenuse side, the longest side of the right triangle, or the side of the triangle that is opposite to the right angle. So we have AY over A, or AY equals the magnitude A sine of this angle theta. So this is the magnitude of the y component. How about the magnitude of the x component? Now, if you're going to get the cosine of this angle, cosine of the non-right angle of a right triangle, cosine of that is the adjacent side, A of x, over the hypotenuse side, the longest side of the right triangle, which is A. So the x component, the magnitude of the x component is equivalent to the magnitude of vector A times cosine of each direction, theta. So this is the x component. X component. But how about the magnitude of vector A? Using Pythagorean theorem, the square of the hypotenuse side is equal to the square of the leg plus the square of the base. That's Pythagorean theorem. Since this is a right triangle, we form a right triangle out of vector A, the y component, and the x component. We can see that the square of the longest side, which is the magnitude of vector A, is equal to the square of the leg, which is the y component, we have ay squared, plus the square of the base, which is a of x, so you have a of x squared, or a is equivalent to square root of the x component plus the square of the y component. So this is the magnitude of vector A. Okay, so that is the magnitude of vector A. How about this angle, theta? Angle theta. Now, if you get the tangent of that angle theta, the tangent of an angle is equivalent to opposite side over the base adjacent side a of x, or theta is the inverse tangent of ay over the x component. Suppose we are going to find the sum of these three vectors, vector A, vector B, and vector C, and the sum of these three vectors is represented by R. I will name the sum of these three vectors as vector R. Each vector has its x and y component. Suppose this is the position of A, vector A, this is the position of vector B, and this is the position of vector C. And we have here theta of A as the direction of vector A, theta of B as the direction of vector B, and theta of C as the direction of vector C. Okay. In graphical method of determining the sum and the difference of vector, we need to put or place the tail of the succeeding vector to the head of the preceding vector. This is the tail of the first vector, tail of the second vector, and this is the head of the first vector. So I place the succeeding vector, the tail of the succeeding vector to the head of the preceding vector. Okay, so again, each vector has its x and y component. So you have a of x as the x component of vector A of y as the y component of vector A, b of x as the x component of vector B, and b of y as the y component of vector B, c of x as the x component of vector C, and c of y as the y component of vector C. The resultant vector, or the sum of these three vectors, by using graphical method, is drawn from the tail of the first vector to the head of the last vector. So this vector is represented by vector R, since that is the sum of these three vectors, vector A, vector B, and vector C. Since this is a vector, it means it has its x and y component. The length of this line, the length of this line represents the y component, or r of y. And the length of this line from the origin to this point represents a of x, r of x, r of x. Okay, so it means this is the x component of the sum of these three vectors. So let us take a look at the y component of vector r. From this point to that point, this is the length of the y component of vector c. And then from this point to this point, the distance from this point to that point is the magnitude of the y component of vector b. This is by. And then from this point to that point is the distance or magnitude of a of y. And this length represents r of y. As you can see, if we're going to add all y components, c of y, py, and a of y, it is equivalent to r of y, or the y component of vector r. Let us write R of y equals ay plus by plus cy. Right? And what is this ay? Ay is the magnitude of vector A, sine of its direction, which is theta of A, plus what is this b of y? B of y is equal to the magnitude of vector B, which is B, sine of its direction, which is theta of B, plus what is this C of y? It is the magnitude of vector C, sine of its direction, which is theta of C. So this is the magnitude of the y component of vector R. All right. Now, how about the magnitude of R of x? Now, from this point to that point, that is C of x. The length of this line, or the distance between these 2 points, is C of x. And the distance between this point and that point is B of x. And the distance from the origin to that point to this point is A of x. As you can see, the sum of 3 x components, A of x, B of x, and C of x, is equivalent to R of x, or the x component of vector R. Or R of x equals AX plus BX plus CX. But what is this A of x? This is equivalent to the magnitude of vector A, cosine of its direction, which is theta of A, plus B of x. What is B of x? That is the magnitude of vector B, cosine of its direction, which is theta of B, plus what is this C of x? C of x is the magnitude of vector C, cosine of its direction, theta of C. So this is the x component. So this is the x component of vector R. Now, how about the magnitude of vector R? Okay, so again, these 2 components, R of y, or the y component of vector R, and x component of vector R, which is R of x, are perpendicular to each other. All right, and then the direction of vector R from positive x-axis is theta. So we form a right triangle out of R of y, R of x, and R. The length of this line of vector R, the length of this line represents magnitude of vector R. Right. By Pythagorean theorem of the right triangle, the square of the hypotenuse is the magnitude of vector R, which is equivalent to the square of the x component, or the base of the right triangle, that is R of x, plus the square of the y component, or the magnitude R is the square root of R of x squared plus R of y squared. So this is the magnitude of vector R. Now, how about theta as the direction of vector R? Since we form a right triangle out of R, R of y, and R of x, okay? The tangent of the non-right triangle, interior angle of a right triangle, tangent theta, is the opposite side, r of y, over the adjacent side, which is r of x, or theta is the inverse tangent of r of y over r of x. So this is now the direction. The direction of vector r from positive x. So this is the direction of vector r from positive x axis. Counterclockwise direction. So vector r is equal to the magnitude, which is r, comma, direction theta. So let us try adding vectors using their components. Suppose given our vector A, which is 5 meters, 85 degrees from positive x-axis, and vector B is 10 meters, 30 degrees from positive x-axis. And then we represent vector R as the sum of these two vectors, vector A and vector B. We're looking for vector A plus vector B. Okay, using their components, the first thing to do is to find the x and y component of the sum of vector A and vector B, which is vector R. So let us find first the y component of vector R. The y component, which is r of y, is equal to a of y plus, since you have plus vector B, then we need to have plus py. And what is this ay? This is the component of vector A, sine of its direction, which is 85 degrees, plus by, sine of its direction, which is 30 degrees. Or what is A? The magnitude of vector A, which is A. We have 5 meters sine of 85 degrees plus B, the magnitude of vector B, which is 10 meters sine 30 degrees. Okay, so what is 5 meters sine 85 degrees plus 10 meters sine 30 degrees? You can check that using calculator, and that is equal to 9.99, I think. Okay, 9.99. You can use your calculator to double check. So this is r of y. Now, how about the r of x, or the x component of vector r? So r of x is a of x plus, since you have plus vector b, so plus b of x. A of x is equivalent to the magnitude of vector A, which is A, cosine of its direction, which is 85 degrees, plus b of x. What is b of x? The magnitude of vector b, 10 meters, cosine of its direction from positive x-axis in counterclockwise direction till 30 degrees. Okay, and this is equal to 9 point. Okay, do not forget to put the unit in magnitude. So we have r of x, that is 9.10 meters. That is r of x. So you can use calculator to double check if this is correct. Okay, and now the magnitude of vector r, which is r equals the square root of the x component plus the square of the y component. So we have r equals the square root, what is the x component? 9.10. So 9.10 meters squared plus the y component, which is 9.99 meter squared. So we have r equal to 13. You can use calculator to double check. So r here is 13.5 meters. So we have now the magnitude of vector r. How about its direction, which is theta? So again, theta is the inverse tangent of r of y over r of x. So theta here is the inverse tangent of 9.99 over 9.10. So theta is approximately 47.67 degrees. You can double check using your calculator. So we have now the direction 47.67. So let's go back to the x and y component of the sum of these two vectors, vector A and vector B. All components are positive. Okay? In Cartesian coordinate system, at quadrant 1, x and y are positive. At quadrant 2, x is negative, x value is negative, y value is positive. The third quadrant, x value is negative as well as the y component, the y value. And the fourth component, x is positive and then y is negative. So since these two components are all positive, so it means the sum of the vectors, these two vectors, the sum of those two vectors are located in the first quadrant. Okay, so we have 47.67 degrees as the angle from positive x-axis in counterclockwise direction. So we have vector r equals the magnitude r, which is 13.5 meters, comma, the direction 47.67.